Hello, I'm Bob Davies, and I'm the CEO of Fibertec. This video blog is the first in a series to introduce you to our products and technology. Our core product is Fibrflex. Fibrflex is a unique, patented, and disruptive technology. Here you see our Fibrflex toe being tied into a knot, demonstrating its excellent flexibility. You can tie it in a knot without the toe breaking. Fibrflex can be used to make many types of textile preforms, such as braids, this is a braid using carbon nylon 6, or fabrics. This happens to be fiberglass with nylon 6. In addition to standard textile processes, it can also be used to make preforms using advanced fiber placement technology, such as tailored fiber placement, or toe placement, or filament winding. This photo demonstrates how easily drapable the Fibrflex fabric is. Here it is being draped over the male portion of a tool. Okay, the process coats the toes individually. This allows us to closely control the resin distribution and the profile of the toe as we make it. The device is a Fibertec design that can be quickly replicated as demand dictates. The matrix resin is a thermoplastic resin, which is pellets, comes as pellets similar to that is used in an injection molding. It is recyclable. It's non-toxic, non-hazardous. We do not have any hazardous waste requirements for this material, and there's no shelf life. Resin is melt extruded onto continuous structural fibers such as carbon fiber, as I have in my hand here, comes on spools. Similar fiber would be glass fiber. Has different mechanical properties, and the design of the part, the requirements of the part would dictate which of these fibers you would use, or other types of fibers such as aramids or Kevlar, which here's a sample of Kevlar that's been coated. The final toe, again, as comes off our machine, is wound onto the spool, as you can see here. So we to go from resins and fibers through the machine, taken back up on a spool that can then be put on a shelf and then distributed as needed to the various textile processes such as fabrics or braids or the textile preforming technologies like tailored fiber placement. So it's very deployable after you've committed the resin and fiber, and it can be used in many, many applications. So far we've talked about the process we use to develop Fibrflex, the flexible toe that can be made into preforms that can be then used to make something useful. And that's what we'll show you now. Composite parts, such as this is a housing, carbon fiber, nylon. As you can see, it's very rigid, very complex shape. Or other parts, such as this control handle, as you can see, as well as a tubular structure that was also made with Fibrflex. May be tough to see, but there's also molded in bosses that are very difficult to do with conventional processes. Computer bezels, again, here it has a rib molded into the back side of it, or other types of computer housings with injection molded bosses, as well as injection molded components added to the composite after it's molded. Now, you may wonder, okay, what about the strength? Just like steel, the thermoplastic composite materials give you virtually the same mechanical properties that you would get with a conventional thermoset system. But what it brings to the table is it's, number one, it's an environmentally safe product. It can be recycled, does not have shelf life, and you have a lot of properties that can be obtained using thermoplastic resins that are superior to that of most thermosets, such as damage tolerance. But the advantages being it's rapidly processed using heat and other words, to make this part into this material, to make this material into this part, all that's required is matched metal molds in a press and heat. The heat, as you put the material in here and you press it down, you heat the material up to melt point. As soon as the material reaches the melt point, it evacuates the air under the pressure. You cool it down and you have a rigid part. So our process is limited by how fast you can heat and cool the tool, not by how fast the epoxy can go through a cycle of curing, which can be sometimes very lengthy. I hope this brief video has been enlightening and informative.